March 15, 1943. RAF Coastal Command Station, St. Evell, Cornwall. A B-24 Liberator sits on rain-soaked tarmac, its four engines warming in the pre-dawn darkness. Inside the fuselage, Flying Officer James Dudley checks his equipment one final time. Something is missing. There are no bombs in the racks, no depth charges slung beneath the wings, no torpedoes waiting to be released. Instead, mounted in a streamlined housing extending from the aircraft's tail, is something strange. It looks like an oversized beer barrel wrapped in copper wire, covered in unfamiliar electronics. The ground crew had no idea what it was. Some guessed a new radar system. Others thought it was a navigation aid. None guessed the truth. Within 6 hours, that device will locate a German U-boat prowling beneath the Atlantic Ocean. Without touching the water, without transmitting a signal, without giving the submarine any warning it has been found. The U-boat's crew will have no idea they've been detected until Dudley's aircraft banks sharply overhead and depth charges begin their fatal descent. The technology responsible sits silently in the tail boom, not transmitting, not pinging, not revealing itself. It is listening. Listening to tiny distortions in Earth's magnetic field, caused by a steel hole 30 meters beneath the waves. Dudley adjusts his headset and studies the unfamiliar dials. The needles rest at 0, but he knows what to watch for. A twitch, a deflection, a disturbance that shouldn't exist unless something large and metallic is hiding below. The scientists who briefed him talked about flux density, gamma measurements, and magnetic anomalies. Dudley thinks of it more simply. The device finds steel that doesn't want to be found. This is the story of the airborne magnetic anomaly detector, the weapon that transformed submarine hunting from educated guesswork into precise science, one of the most audacious technological leaps of World War II. Britain on the edge. By early 1943, Britain was approaching catastrophe. German U-boats were sinking Allied shipping faster than it could be replaced. In the first 20 days of March alone, 97 merchant ships were sunk, carrying over 627,000 tons of desperately needed supplies to the bottom of the Atlantic. The mathematics were brutal. If losses continued at that rate, Britain would be starved into submission before American industry could fully turn the tide. Every convoy was a gamble. Every merchant sailor understood the odds. Of the 185,000 men who served in the British Merchant Navy, 36,749 never returned, a higher casualty rate than any branch of the armed forces. German wolf packs had refined their tactics to lethal efficiency. Groups of 15 to 20 U-boats spread across convoy routes like a net. One boat spotted a convoy, shadowed it, called in reinforcements, then attacked at night when visual detection was nearly impossible. Surfaced U-boats could outrun escort ships. Submerged boats slipped beneath convoy screens. Admiral Karl Donitz, commander of the U-boat fleet, believed he needed to sink 700,000 tons of shipping per month to win the war. In March 1943, he was exceeding that target. Detection had failed. Existing submarine detection methods had reached their limits. ASTIC, early sonar, worked only when a ship passed almost directly over a submerged submarine. Its effective range was about 1,500 meters, under ideal conditions that rarely existed in the North Atlantic. Rough seas, temperature layers, and engine noise all degraded performance. Against surfaced U-boats at night, ASTIC was useless. Radar helped, but only at short range. German lookouts learned to spot aircraft visually long before radar detected them. A U-boat could dive in under 30 seconds. By the time an aircraft arrived, the submarine was already deep. Visual search was worse. A U-boat's conning tower was barely 2 meters wide, often less than 1 meter above the waterline. Pilots stared at endless gray ocean under gray skies, spray and whitecaps creating countless false targets. They saw submarines everywhere and missed the real ones entirely. The numbers were devastating. In 1942, Coastal Command flew 35,000 anti-submarine sorties. They sighted U-boats 218 times, pressed attacks 74 times, achieved 5 confirmed kills. 1 U-boat destroyed for every 7,000 flight hours. That wasn't sustainable. Something fundamental had to change. A radical idea. The breakthrough came from the Admiralty mining establishment in Hampshire. The insight was simple and radical. A submarine, no matter how deep or silent, carries an unavoidable signature. Steel distorts Earth's magnetic field. A Type 7 U-boat displaced around 760 tons, most of it steel. That mass had to bend the planet's magnetic field. The challenge wasn't theory, it was engineering. Could that distortion be detected from a vibrating aircraft moving at speed amid natural magnetic noise? The answer became the Type F Mark II magnetic anomaly detector. At its heart was an ultra-sensitive magnetometer capable of detecting variations as small as 1 gamma, about 1/150,000th of Earth's magnetic field, sensitive enough to detect the disturbance caused by a steel filing cabinet from 30 meters away. Engineering the impossible. The aircraft itself produced a massive magnetic field. Detecting a submarine from inside it was like hearing a whisper inside a factory. Engineers solved this by mounting the detector in a tail boom far from engines, using compensation coils to cancel the aircraft's magnetic signature, measuring changes, not absolute values. Submarines produced sharp, narrow spikes. Geological features produced broad, gradual variations. Once trained, operators could tell the difference instantly. The device weighed 68 kilograms. It could be retrofitted to existing patrol aircraft. Under ideal conditions, a submerged Type 7 U-boat could be detected from 150 meters altitude if the aircraft passed within 120 meters. Depth mattered. At 10 meters, detection was reliable. At 30 meters, difficult but possible. Below 50 meters, detection became unlikely. Ironically, U-boats hunted convoys at 10 to 20 meters, exactly where MAD was most effective. Into combat. Operational deployment began in March 1943. Initially, just 12 Liberators were equipped. Crews were hand-selected. MAD didn't tell you depth, it gave bearing and anomaly strength. Crews circled contacts, dropped sonobuoys, confirmed with ASDIC, then attacked. The first confirmed kill came March 19, 1943. Flight Lieutenant John Roxborough, flying Liberator AM-924, detected a magnetic anomaly southwest of Ireland. The sea looked empty. Visibility was perfect. The detector insisted otherwise. Roxborough circled, dropped a sonobuoy. ASDIC confirmed a contact at 30 meters. 8 depth charges followed. U-384 never surfaced. 48 men died without ever knowing what had found them. The real impact. Between 1943 and 1945, MAD was directly credited with 15 to 23 confirmed kills. That number misses the point. MAD multiplied patrol effectiveness. Aircraft covered 3 times the area. U-boats dove deeper. Battery endurance suffered. Surfacing became deadly. German crews reported attacks with no warning, in perfect concealment. The ocean had betrayed them. The Germans never fully understood why. Some tried degaussing, others dove deeper. None solved the problem. Steel cannot be magnetic without ceasing to be steel. Legacy. Modern patrol aircraft still carry MAD systems. The principle hasn't changed. Iron cannot hide from magnetism. March 1943. The Liberator climbs into darkness. Below, the Atlantic stretches black and endless. U-boats still believe invisibility protects them, but steel remembers, and magnetism listens. Before the war ends, 630 German submarines will rest on the ocean floor, their steel hulls still bending Earth's magnetic field. The sea may hide from the eye, but it cannot hide from physics, and in that truth lay the difference between convoys sunk and convoys saved.